All right, the classic Greek definition of a parabola. You have two things. You have a point here. This point is called the focus. And then you have a line, like so. And this line is called the directrix. The parabola is all the points on the graph that are the same distance from the focus to the directrix. So for example, one of the points is right here, and I drew my focus and my directrix very specifically so that that point would be on the origin. Because this distance and this distance are exactly the same. So there's one point on the parabola. Another point might be like over here somewhere. So what would have to happen is this distance and this distance would have to be exactly the same for that to be a point on the parabola. That's the Greek definition of a point on a parabola. The distance from the focus and the distance to the directrix, where this makes a right angle here, the distance from the focus and the distance from the directrix have to be exactly the same. So another point would be like up in here somewhere, and this point, this distance here, would have to be the exact same as that distance there. And of course, we then get a whole bunch of points along like so. And we get a parabola that looks sort of like that. All right, so what we want to do is we want to come up with the equation of that parabola. This distance, the distance from the vertex to the focus, is traditionally called P. Why they use the letter P, I have no idea. And then the distance from the directrix to the vertex is also the exact same distance. It's also P. So, if the distance from the vertex to the focus is a length of P, what's the coordinates of this point right here? What's the x value and the y value? X is 0. Why is x 0? Because it's right on the axis. And the p and the y value is what? Not 2. P, whatever that distance is. So this point right here, this focus, is the point 0, P. Okay. How about this directrix? What's the equation of this line? It's a nice horizontal line. Not x equals. Horizontal lines are y equals. Y equals what? Say that again. Well, it's a line, so it can't be infinity comma p. It's got to be just an equation. Y equals negative p. This is a line y equals negative p. I mean, if I go to any spot on this line, what's the y value? The y value is negative p. It doesn't matter what the x value is. Okay. So I'm going to pick a point on this parabola. I'm going to pick this point right here. And I'm going to call it x comma y. If this point is on the parabola, then what has to happen is this distance has to be exactly the same as that distance. How do you find distance between 2 points? You use a distance formula. All right, so what's the distance formula? Square root of, get it right. Usually we go x2 minus x1 squared plus y2 minus y1 squared. Usually do it in that order. Okay, so let's start with this distance right here. This one's the easier one. This point is x comma y. What's this point down here? What are the x and y values for that point? Well, if this one is x, then down here this is also x. And what's the y point here? What's the y value? Negative p? We don't know what p is, it's just some number. So this distance is, from here to here, is the square root of, what happens when I do x2 minus x1? I get x minus x, which is 0. So that's 0 squared plus y minus negative p. I'm going to write it as y plus p squared. All right, so that distance has to be exactly the same as this distance. Well, this distance is square root of, I subtract the x numbers. That's x minus 0 squared plus y minus p squared. All right, big mess. We're going to simplify it though. How can we simplify? I think what I'd really like to do probably is solve for y, because usually when we have graphs like this, we write y equals something, something, something. Absolutely. We can square both sides. That makes things a lot better already, because that gets rid of those ugly square root things, doesn't it? All right, so this is y plus p squared equals x squared plus y minus p squared. On the left, I'm going to take this and just expand it. So if I multiply that out, I get y squared plus 2py plus p squared equals, and I'm going to do the same thing on the right hand side. I've got the x squared, and then I'm going to expand this. That would be y squared minus 2py plus p squared. And then some really nice things happen. What are the really nice things that happen? If I subtract p squared on both sides, they're going to add up to 0. I can add the 2py over here. What about the y squareds? Same deal, subtract the y squareds, they go away. I'm going to add 2py to both sides, and I get 4py equals x squared. And this is the form of the equation that the Greeks used for parabolas, where this p is a very important number. What's p again? It's the distance between the vertex and the focus. It's also the distance from the directrix to the focus. Two very important things. P would be the distance from the focus to the directrix, absolutely. Yep. Now, this equation that we have gives us a parabola that has a vertex right at the origin. What if I didn't want the vertex to be right at the origin? What if I wanted to shift the vertex right and up, for example? What if I wanted to do a translation? You did that back in 1411. How do you translate things? Negatives and positives, that's correct. So, quite often we see this written as 4p times y minus k equals x minus h squared. So, nope, it actually goes, because of the minus, it goes right, and because of this minus, it goes up. But of course, h might be negative 2, so you'd have x minus negative 2, which would be x plus 2, and then that would move left. And move backward from what you think. All right, so this has a vertex. Go ahead. I could. I didn't want to have fractions. I liked having a number over here. I could divide both sides. I could write this as y equals 1 over 4p x squared, but I wanted to avoid fractions. That's all. No reason not to. Now, sometimes we like our parabolas going up like this. Of course, sometimes we have parabolas that go down. What would be the difference between a parabola going up and a parabola going down? How could I take this equation right here and make the parabola go down? You guys are thinking too hard. The way you've dealt with parabolas before, you've written them that way. When did the parabola go up? When a was positive. And when did the parabola go down? When a was negative. So when is this parabola going to go up? When p is positive. And when is this parabola going to go down? When p is negative. Correct. Okay. Now in this section we're even going to do more. Sometimes instead of having parabolas go up or go down, sometimes we're going to have parabolas go sideways. How does the equation change if I want the parabola to go sideways? Say it again. Nope, not fractions. The y's are going to be to go up and down. The x's are squared. How do we make it go left and right? The y's are squared. So we're basically going to have two different equations here in this section. We're going to have 4p times y minus k equals x minus h squared. This parabola goes up or down because it has the x squared. It goes up when p is positive. It goes down when p is negative. And it has a vertex of h comma k. The other equation we're going to have 4p times x minus h equals y minus k squared. This one goes right or left. When does it go to the right? When p is positive. And when does it go to the left? When p is negative. Up and down, left and right, same idea. And this one still has a vertex of h comma k. Now, for the vast majority of the problems we're going to do in this section, it's going to be even easier because for the vast majority, our vertex is going to be at the origin. So we won't have the y minus k, we won't have the x minus h because h and k will both be 0. But some of the problems we will. All right, so did you bring back that sheet that I passed out the other day? Okay, so we have y equals 1/8 x squared. It says determine the vertex, the focus, and the directrix of each of the following, and then draw a rough graph. My first question to you would be, does this parabola open up, down, left, or right? That's an up. Why is it an up? Because it's a positive and it's an x squared. That tells you it opens up. Where's the vertex? How do you know the vertex is at 0, 0? There's no h and k. There's no y minus a number. There's no x minus a number. So the vertex is very easy. The vertex is 0, 0. So over here I'm going to start my rough graph. 0, 0, right there. Now, in order to find the focus in the directrix, I need to write my equation this way, because I need to know the p number. Find the focus in the directrix. So I think what I want to do is I want to first take this equation and multiply both sides by 8. So I would write it as 8y equals x squared. I want the x squared all by itself, like so. And then, what's the p number? Not 1. Not 8. 2. Why 2? Because we need to write this left-hand side, we need to write it as 4 times something. 4 times what will give me the number 8? 2. It's always, always, always has to be 4 times something. The 4 is always in the formula. So I would write this as 4 times 2y equals x squared. So p is the number 2. If p is the number 2, and this parabola is going upward like so, then where is the focus? 0, 2. The focus would have to be straight up 2 units because p is 2. So our focus would be right there, 0, 2. Well, the directrix wouldn't be 0, negative 2. The directrix is a line. Y equals negative 2 would be the directrix. So directrix y equals negative 2. Okay, so when I say a rough sketch, I really mean that rough. I just want you to show me that the parabola is opening up. I want you to mark the vertex, mark the focus, draw the directrix. So that's how rough I really want those graphs. Nothing fancy at all. All right, how about x equals negative 1/16 y squared? Up, down, left, or right? Up. Down? One of those four. Up, down, left, or right?
Well, it's y squared, so it's left or right.
It's y squared, so it's left or right? That's a negative, so it's left. So the y squared tells me left or right. The negative tells me it's going to be left. Where's the vertex? Vertex is still 0, 0. All right. So again, a very rough graph. Vertex is there, and it's opening left. So it's got to look like that. Next, I need to know the p number. What's the p number? Close. Negative 4. How'd you get negative 4? Right. You want to write this as negative 16x squared, equals y squared. And then it's got to be 4 times something. And in this case, it's 4 times negative 4x equals y squared. So in this case, p is negative 4. If p is negative 4, where's the vertex? Yeah, but I said vertex. Vertex is still at 0, 0. So that's a better question would be where's the focus? So where's the focus? It's got to be in here. So it's at negative 4, 0. Focus. Negative 4, 0. And how about the directrix? Excellent. This time the directrix would have to be a vertical line. The equation of a vertical line is x equals a number. So in this case, it's x equals 4. Questions on that one? Problem C. Left or right, up or down? I hear a vote for up.
Yeah.
I hear a vote for down. I hear another vote for down. Somebody wants to go left or right? It's negative, so it's down. So I see two things. I see that the x is squared. That tells me up or down. Over here, I see that this number is negative. That tells me down. So this one's definitely a down. Where's the vertex? Not 2, -3. -3, 2. Why -3, 2? The 3 goes with the x number, and the 2 goes with the y number. So when I write them here, I got to write them in that order. And remember, it goes backward. If I have an x plus 3 here, it's going to move it left. So the vertex is at -3 and 2. All right, so starting the graph here. -3, 2 is right there. And we said it's going down. Down, 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 like so. All right. You get a p number for me? P is -3 because we would write -12 as 4 times -3. Good. Okay, so if P is -3, where's the focus? That might be the directrix. The focus should be a point. It should have an x number and a y number. -3, -1. And how did you decide your final answer was -3, -1? All right, so to find the focus, you start at your vertex and you move by the p number. So I start here and p is -3, so I got to go straight down 3 steps. So the focus is -3, -1. Right there. And the directrix, I would start at the vertex and have to go up 3 steps. So where would my directrix be? Y equals 5, because I start at 2 and I go up 3. So my directrix is the point, -3, 5. Or not a point, directrix is a line, y equals 5. Question so far? All right. D, up, down, left, or right? Correct. Y is right, correct. We have a y squared, and that number right there is a positive, so that's a right. Where's the vertex? -1, 4. Why is it at -1 and 4? Because it's x plus 1, so that shifts it left 1. And then it's y minus 4, that shifts it up 4. That's exactly correct. All right. The 2 has absolutely nothing to do with the vertex. The 2 has stuff to do with the focus and the directrix. Just like in this problem, this -12 had absolutely nothing to do with the vertex. The vertex comes from the things inside the parentheses. That's all. -1, 4. Right about there. And we decided we're going right this time. So, what's the p number? One over 8. How in the heck did you get 1 over 8 out of that? Okay. So what's that 2 have to do with stuff? right, so first we need the thing with the square to be all by itself. So first we got to divide both sides by 2. So I'm going to write it as 1/2 times x plus 1 equals y minus 4 squared. And then this number that's a 1/2, I need it to be 4 times something. 4 times what gives you a 1/2? Her answer was correct. That's 1/8. So it's 4 times 1/8 to get that 1/2 back. All right, so we had to rewrite that one a little bit first. So p can be an ugly little fraction like that. That can happen. Here's a good example. P can be the number 1/8. So if P is the number 1/8, where in the world is my focus? Well, in this case, I would start at the vertex. In which direction would I move to find the focus? You're moving the wrong direction. Since my parabola opens this way, my focus is going to be in here. So the y number is not changing. What's changing? The x number changes this time. So my focus is in here. The y value is still going to be 4 because it's moving straight to the right. My x value is changing. So I need to take -1 and add 1/8. What's -1 plus 1/8? -7/8. You gave me 1 plus 1/8. It's -1 plus 1/8. All right, so our focus is -7/8, comma 4. And finally, my directrix is over here. It's x equals, I have to start at -1 and then move 1/8 to the left. So in other words, it's -1 minus 1/8, which is -9/8. So I really think it helps a lot, at least it helps me a lot, to draw the pictures. And once I know my vertex, I then know if I should add to my x numbers or my y numbers. If my parabola is opening left and right, I know it's my x numbers that are going to change to find my vertex, to find my focus and my directrix. If my parabola is opening up and down, then it's my y numbers that change to find the focus and find the directrix. So to me, it's very, very helpful to draw the graph. Some people don't like to draw graphs, so they don't. How about this one? Y equals x squared minus 8x plus 2. Unfortunately, it doesn't factor. That was a good idea, it doesn't work. Does this one go up, down, left, or right? Up. Up because x squared and positive in front of it. That's all you can tell me. Opens up. That is the start. Can you find the vertex for me? Well, am I going to have to go speak to your Math 1411 teacher about you guys not knowing how to find the vertex? Not -8, -2. All right, so there are two ways to find the vertex here. Option number 1 is a technique called complete the square. Option number 2, there's a nice little formula for finding the vertex. Anybody remember the nice little formula for finding vertex? Does anybody remember the quadratic formula?
Yeah.
What's the quadratic formula?
B plus or minus the square root of b squared minus 4ac over 2a.
There's the quadratic formula. And it's funny that you guys can remember that, but you can't remember the vertex formula.
There's a song for that.
Oh wait, is that?
There is a song. It's very annoying. I played it about an hour ago. The formula for the vertex is you cover up that square root stuff, and there's the formula for the vertex. The formula for the vertex is negative b over 2a. So if you know the quadratic formula, you really know the vertex formula. You did the hard part. It's negative b over 2a. All right. So using that, x equals negative b over 2a. That's going to be 8 over 2, which is 4. And then how do I find the y number? I simply plug it in. That's correct. So I plug it in. What's 4 squared? 8 times 4. 16 minus 32. Negative 16 plus 2. Negative 14. So the vertex is 4, negative 14. So what that tells me is I can take this equation and I can rewrite it this way. I can write it as y plus 14 equals x minus 4 squared. And that's a nice trick which allows you to avoid having to do that complete the square process. That's true. There's no nice number that 4 times something gives me 14. Truth is, I really don't care about that. I got to find p? I do have to find p. So I need 4 times something times y plus 14 to equal x minus 4 squared. So what's p? P should be 1/4. The 14 has absolutely nothing to do with finding the p number. The 14 only has to do with finding the vertex. The p number is completely separate from finding the vertex. 4 times 1/4 is 1. Right, the p number comes from the number that's out front here, and the number that's out front here is a 1. Alright, so I'm running out of room here. I'm not going to try to squeeze it in. We have our equation written as 4 times 1/4 times y plus 14 equals x minus 4 squared. Alright, so we decided that our vertex was at 4, negative 14, way down here somewhere. It opens, we said it opens up. It's that way. Where's the focus? So the x number is 4. And to find the y number, I add a quarter, don't I? So what's negative 14 plus a quarter? Negative 13 3/4. All right. So negative 13 3/4. Or, worst case scenario, you take 4 times 13 and then you add the 3. And you put it as an improper fraction. Negative 57 over 4. Also work. All right, and then how do I find the directrix? Y equals negative 14 and a quarter, or negative 14.25 if you prefer. Again, you could write it as an improper fraction if you so choose. I don't care. Very flexible. I care that it's correct. I would accept negative 14 and a quarter. I would accept negative 14.25. I would accept negative 57 fourths. I would take any of them, as long as they're all correct. Very flexible. They're all the same thing. That's why I'll take them all. All right, how about this last one? On the front side. How about the back side of it, too? X equals 4y squared minus 12y plus 16. How do I find the vertex? You use x equals negative b over 2a when it's the x's squared. When it's the y's squared, it's y equals negative b over 2a. The same little formula works. So y equals negative b over 2a, which is negative 12 over 8. No, positive 12 over 8. Still not much better. Which looks like it's about 3/2. Don't know that I'm a big fan of that. Then what do? I gotta take 3/2 and plug it in, don't I? So 4 times 3/2 squared minus 12 times 3/2 plus 16. X is 7. So what that tells me is I can write this equation as x minus 7 equals 4 times y minus 3/2 squared. Why is the 4 there? Yeah, because what really has to happen here, think of if I FOILed this out. If I FOILed this thing out, the very first thing would be a y squared, wouldn't it? But it to be the same, I need it to be 4y squared. So I need to have this 4 out front so that when I FOIL this back out, I get the 4y squared back. And then if you FOIL this out, you'd have to multiply by 4 to get the negative 12 in the middle and the 16 on the end. So whatever number is out here, that number is going to stay out there after you pull it out. All right, and then I think I need to write this as 1/4 times x minus 7 equals y minus 3/2 squared. All right, so I can start drawing my picture. I have 7 3/2. Right about there. Left, right, up, or down? Right, because it's y squared and that's a positive, so it goes this way. What's the p number? Not 4. $16? Closer. Well, actually it's further away, but I need 4 times p to give me 1/4. I got 1 over 16. P is 1 over 16 of the little fraction. All right, so that tells me my focus is here. So to get my focus, what do? way am I moving? Am I moving left or right? Or up or down? Right. Moving right changes which values, x's or y's? X. So I should take 7 and add 1/16. So it should be 7 and 1/16, 3/2. And then my directrix, I would take 7 minus 1/16. I don't know what that is. I'm just going to write it as x equals 7 minus 1/16. I'm going to be lazy. You could grab your calculator and type it in and do that on your second. 111 over 16. All right, now we flip the paper over and we go the other way. What I mean by the other way is on this side, I gave you the equation and I asked for information. On this side, I give you information and I ask for the equation. And again, for me, it helps to draw a little picture. It says vertex at the origin and focus 0, -3. So if this is my vertex and this is my focus, which way does this parabola go? Left, right, up, or down? Down. It's got to surround the focus. So the parabola goes this way. Which tells me my equation has to be 4py equals x squared. The x has to be squared because it goes down. My vertex was at the origin, which means I don't need x minus a number or y minus a number. What's the p number? The p number is -3 because p gives us the distance from the vertex to the focus. In this case, since we're going down, p is -3. So our equation would be -12y equals x squared. That's it. Yeah, that one wasn't so bad, was it? All right, next one. We have vertex at the origin, that's right there. Directrix is x equals 5. That's x equals 5. Which way does it go? Left, right, up, or down? Left. Why left? It goes away from the directrix. All right, so this one goes left. Since it goes left, what does that tell me my equation has to be? What form does it have to take? 4p times what? X equals y squared. It has to have the y squared since it's going left. And so what's the p number this time? Close. -5. Why is p -5? This is going left. Our focus would be over here. So p equals -5. So this one's -20x equals y squared. It's almost easier, isn't it? It's almost easier when I give you the information and ask for the equation. Well, let's see if it gets harder. Vertex is 1, 2. 1, 2 is right there. And focus is in here at 4, 2. All right, left, right, up, or down? Right. Got to surround the focus. Since it goes right, what does my equation have to look like? 4p x. It's not just x this time though, because the vertex has moved. So it has to be x minus 1 equals, it's not just y squared, y minus 2 squared. And the only thing I need to know is the p number. P is 3 because from 1, 2 to 4, 2, that's a distance of 3. P is 3. So this is 12 x minus 1 equals y minus 2 squared. All right, the last one. Vertex, negative 3, 1. That's right about there. And directrix, y equals 4. It's up here. Up, down, left to right. Down, because it has to go away from the directrix. So my equation has to have x squared or y squared. X squared, since it's going to go down. So it's 4p y minus 1, because of the 1 in the vertex, equals x plus 3 squared. And then again, what's the p number? Negative 4, not negative 4. Negative 3, because it would be this distance. That distance is 3, but because it's going down, it's a negative 3. Yeah, easy to say negative 4 on that one, I agree. So, final answer, it looks like negative 12, y minus 1 equals x plus 3 squared.